Okay, so we spent the last couple of topics talking about our atom, the nucleus with the positively charged protons and the neutral neutrons, and the negatively charged electrons orbiting around the outside in their shells. We also spoke about the fact that the number of protons defines the element, that if you have 9 protons in your atom, you have fluorine. If you have 12 protons in your atom, you must have magnesium. 30 protons in your atom, by definition, it must be zinc. Make sure you've got your periodic table handy. It's going to be a big part of this topic. We're going to talk about how all the atoms are arranged inside our periodic table, some of the hidden information we get from that. Let's start by having a look at the history of our periodic table and how it came to be the way it is today. Originally, it was designed where the elements were just laid out according to increasing mass. That was it. Then, in 1864, John Newlands, in the face of much ridicule I might add, noticed and thought that there might be a recurring pattern and that the elements behaved quite similarly once every 8 elements, that there was this repeating nature. A few years later, Dmitri Mendeleev organized a more structured version of a periodic table where he arranged the atoms according to the similar chemistry and behavior of each of the different atoms. What was truly fascinating about his arrangement, however, was that when he was lining atoms and elements up according to the way that they behaved, rather than trying to force them into areas, he instead postulated that there were things missing in the periodic table. He placed question marks where he felt atoms should be that we simply didn't know about yet. He went one step further than that. He said, I think there should be an atom here, and I think it should behave like this. It should melt at about this temperature, and it should form these kinds of compounds. What's truly amazing about these predictions is many of them came to be true. So clearly he was onto something in his arrangement and structuring of the periodic table, aligning the elements according to their chemical properties. In 1913, Henry Moseley then did some experiments where he was bombarding atoms with electrons, so projecting electrons at them at a high speed, and when this happens, those atoms were emitting X-rays. As it turns out, the X-rays that are emitted, the energy that they have can be directly related to the number of protons inside the nucleus of the atom. So what that allowed Henry Moseley to do was to arrange the atoms in order according to how many protons they had, one after the other. If you combine the work of Henry Moseley with that of Mendeleev, they then had a lot of the information they needed to help build the periodic table as we have it here today. Henry Moseley's work was also incredibly interesting because in his data he found that there were holes and gaps missing, and he also predicted that there might be elements there. His work led to the discovery of a few previously unknown elements, including technetium, which to me is one of the amazing ones because it is a largely synthetic element. It occurs naturally almost nowhere on Earth, so without his work we simply may never have known of its existence. So quite a few people to thank for the periodic table that we have today. Let's improve our ability to speak chemists. We're going to talk about how we refer to the periodic table and the various regions around it. That will be our major focus for today. So it's arranged in columns and in rows. We don't call the columns columns, we call them groups. So here I've highlighted a group for you. There is a little bit of debate about the right way to number the groups. That has changed over the years. The current international system that's being recommended is that they are simply numbered 1 through 18 across the top of the periodic table. I, however, am going to use a slightly different system, a more antiquated system, because it will help us in our second module of study. You'll notice in blue that I've got group numbers written across the top of the periodic table in Roman numerals. So we've got group 1 and 2 on the left, and then we skip across and we've got groups 3 through 8 on the right. I will frequently refer to those group numbers, particularly when we get into that second module. So columns on your periodic table, they are called groups. Rows, as we move across your periodic table, I'm pleased to say, are simply called rows. So how is your periodic table arranged? What can we notice by looking at it at a glance? Here I have it highlighted according to whether the elements are metals or non-metals or something in between. You can see that most of the periodic table is actually made up of metals. So all of the elements highlighted purple on the left-hand side, they are all metals in their naturally occurring state. In the right-hand side, highlighted in yellow, we have the non-metals. You'll notice that hydrogen, hiding up in the top left corner, that's actually a wannabe non-metal. It belongs on the right-hand side of the periodic table when it comes to its behaviour. We'll talk more about that and why in our second module. So again, mostly metals on the left, non-metals on the right, and we have that middle band, that green highlighted band there. These are called the metalloids or the semiconductors. They're materials that are not quite metals and not quite nonmetals. Their behaviour is a little bit in between the two. Now we're going to move around the periodic table and name various regions and groups of it. I'll refer to these areas by name throughout this subject, so it's good for us to become familiar with them. The first group, group 1 on your periodic table, these are referred to as the alkali metals, highlighted in purple. If we move across one group to the second group, very unfortunate, these are called the alkaline earth metals. I don't know who decided it was a good idea to call those two such similar things, but here we are. So group 1, alkali metals, group 2, alkaline earth metals. We then move into the middle of the periodic table. We refer to these elements here as the transition metals. Moving across to the other side of the periodic table where our non-metals are. In particular, if I highlight group 7, these elements are called the halogens. The last group, group 8 on your periodic table, these are called the noble gases. They are also often called the inert gases. Inert meaning unreactive or non-reactive. And again, we'll talk more about the significance of that in forthcoming topics. And then finally, down the bottom of our periodic table, we have what are called the rare earth metals, or they are sometimes separated into two parts called lanthanides and actinides. So that's a lot of definitions for this topic. I think we'll call it there. What I would like you to be able to do by the time you move on to the next one is refer to the different areas of your periodic table by name so that you and I can communicate more freely in future topics.